Previously, I explained the technical background to one-time authentication code and how it works. But for the sake of better understanding, I'd like to explain OTAC's positioning in the market. If you're wondering about previous videos, check out our other videos in this channel as well. To put it simply, OTAC is a second-generation OTP. In other words, it's OTP 2. OTAC functions as a more advanced OTP by adding the applications algorithm developed by swIDch's to OTP standards. We use OTP standards as they are, but reinforce the functions that couldn't be implemented in existing OTP through the application algorithm. If you're still confused about how OTP and OTP 2 work, let me explain it one more time structurally. As time-based OTP standards are intended for secondary authentication for multi-factor authentication, the server and client have the same structure. When you send an OTP generated by a client to the server simply makes a one-to-one comparison with the OTP generated with the same structure. At this stage, if the server doesn't know the secret key of the authenticator, it can't generate an OTP. This means that first authentication must be preceded before you can find the secret key of the authenticator and make a one-to-one comparison. Now, let's see how OTP 2, the next generation of OTP, works. OTP 2 receives the codes generated by the client from the server and reverses the code to find the ID and secret key for the primary authentication. Since it then creates an OTP itself, it goes through a single process, from first to second authentication. Let's take a look at how it works differently to other authentication technologies. First, I'd like to compare it with OTP. OTP can't be used as a primary authentication, and there is still the possibility of duplication. However, OTP 2 has zero chance of duplication of authentication codes, and the dynamic code alone allows for primary authentication. What about in comparison to ID and password, the most well-known form of authentication? OTP 2 of course replaces ID and password functions with dynamic codes only, in a way that standard OTP can't. Last, let's compare it with tokenization, which is most commonly used when making card payments. Tokenization provides primary authentication with dynamic codes, but requires two-way communication. OTP 2, however, does not require this two-way bidirectional communication because it's a one-way unidirectional technology. Tokenization technology authenticates by sending and receiving tokens in both directions, whereas OTP 2 only uses a one-way authentication process. If we position OTP 2 alongside the other authentication technologies, OTP 2 can be applied not only to existing OTP, but also to other authentication areas OTP hasn't yet reached. On gutless authentication technology quadrants, OTP isn't suitable for new investments. However, OTP 2 is a much more advanced authentication OTP. We can call it the future of OTP and the revolution of authentication technology as it overcomes the limitations of existing authentication technologies. swIDch's believes that OTP 2 will drive the authentication market in the future. OTAC, swIDch's OTP 2 technology, has more than 270 global intellectual property rights and patents as of September 2022. OTAC's algorithm has already been validated by the University of Surrey, one of the UK's leading cybersecurity labs, the TTA in South Korea, and recently passed security verification to allow OTAC to be embedded on EMV chips for global companies. swIDch's OTAC technology is the foundation of our revolutionary OTP 2. If you have any further questions, please contact us.